And okay. All right, I think we can probably get started now. So just good morning, and I just want to welcome everyone again and just say thank you for joining us for Food Production and Sustainability, a panel discussion on the strategies employed by industrial food manufacturers and processors to tackle waste, food waste. And again, this is being recorded. We'll post it online so that we can share the information later. But also, if you have to step away for a minute, don't feel like you're going to miss out on information. My name is Rachel Hauk, and I will be your host. I am also the Executive Director for the Brass Tacks Initiative. And for those of you who don't know, BTI is a nonprofit founded on a mission to support sustainability in the food stream through research, education, and collaboration. So programs like this are just a big part of our mission because they help to spread awareness, information, and solutions to the food waste problem. And so for more information about that, go ahead and visit our website, which you can see on this slide here. You can also just email me directly if you have any direct questions, and my email is on the slide as well, and I'll put it in the chat later on. Before I introduce our panelists, I also want to let you know again that the chat feature is open. And since we have so many people joining us today, the microphones have all been disabled, but if you have a question, please use the chat feature, and we will have question and answer at the end, but I'll also be monitoring throughout the discussion today. So if there's a question, oh, and the panelists will be able to see them. So if they see your question or I see your question and we think we can answer it a little sooner, we'll do so. Otherwise, we'll try to get to them all at the end. And so this will be our agenda for today. We're going to start with just a brief overview of food production and their sustainable initiatives. And then we'll talk about the types of materials and challenges faced by the industry. And next we'll move into technologies. Some of them you've heard of and you've heard frequently, but there are some new and emerging ones that I think are really interesting. And I think also really importantly, our panelists are going to talk about how to incorporate this sustainability without compromising operational efficiency. I think that's something that scares a lot of companies away from implementing sustainability. And then we're also going to talk about the future and the economic landscape. And so I'm going to go back one slide here, and I'm going to introduce our panelists. So these guys have a ton of experience in this field. I'm looking forward to learning from them today. And so help me welcome Todd Fischer from Cannon River Group, Steve Widdicombe and David Russick from Innovative Waste Recycling. And so I'm going to ask each of you to go through and just kind of give like a couple sentences about yourself. And then also maybe just give us your idea of the importance of sustainability in the food stream from your perspective, from your background. And maybe we'll start with Todd, if you wouldn't mind doing that first.
Yeah, sure. No, I wouldn't mind. Thanks, Rachel. Todd Fischer. I live here in Minnesota with my wife and 4 kids. I spent 24 years in the food production industry in various roles, and I spent about the last 5 working with food companies on their sustainability goals. And why sustainability is important for food producers. I think it's important for all industries, I believe, right, to do right by the environment. But I think and we'll talk more about this, as the focus on organics becomes greater, landfill diversion, obviously food companies will be right in the middle of that discussion, just due to the fact that the volume of organics produced in the form of waste and byproducts out of food production is so high. So I think food companies are going to be right in the middle of that conversation. And now's a great time to start considering how to get ahead of some of that regulation before that becomes something that a company is kind of after the fact trying to meet regs. So, and we'll talk some more about that as we go.
Okay, great. Thanks so much for that, Todd. Steve, if you wouldn't mind going next.
Yeah, good morning, and Rachel, thank you for hosting. Appreciate the opportunity. Steve Widdicombe from Minnesota here, just about an hour south of the Twin Cities. My background is in biology and sustainable agriculture. I've spent the last 15 years or so in or around the waste and waste processing industry, initially on the equipment manufacturing and design side, specifically geared towards anaerobic digestion. And then here in the last 8 years, heavily focused on feedstock management for anaerobic digestion compost facilities, and helping food production facilities find a good sustainable fit for their byproducts and waste streams. As far as sustainability, I don't want to give a cliche answer, but I think with limited resources and considering the environment and the state of the environment, I think it's important for us to be as responsible as we can with the resources we have. And so I think really focusing and dedicating time and energy to finding the best use for byproducts and waste streams is really important. So I think that's kind of sums it up from my perspective.
That's great. Thank you, Steve. David, would you mind going next?
Yeah, I'm happy to do so. And I want to thank everybody for joining us. We got quite a crowd. Really happy to see the amount of interest in food waste and sustainability. So I'm the project manager for innovative waste recycling. I'm based on the West Coast, servicing accounts in Washington, Oregon, and California. My background is in waste management, recycling, and I would say over the last 3 or 4 years, focusing on organics. As far as the overview of food production and sustainability and the importance of all this, I think consumers are becoming more aware of what companies are doing in the sustainability space. I can speak for my own kids who are in their 20s. They will research food companies to see which companies have sustainability practices before deciding who they're going to buy from. So I think that's going to become increasingly important for all food manufacturers. And I think in some cases, there are economic reasons, a means to save costs on disposal by landfill diversion. And so we bring that opportunity to the food producers. And then finally, as we're seeing across the country, a handful of states with government mandates requiring food recycling. So we help with that as well.
Okay, great. Thank you, guys. Okay, so you gave, thanks for that overview. I think that gives a pretty good baseline for moving forward with some of the next questions. So next, I would like to know if you guys can address some of the most significant challenges the food industry faces in addressing food waste. And then how do technological innovations play a role in overcoming these challenges? And we will go in depth more into technologies later. So just like briefly how they play a role and the most significant challenges to sum it up.
Yeah, I can take that to start. I think general education. There are food companies out there with significant sustainability departments or a focus on sustainability, and they started that journey 1, 2, 3, 4, 5 years ago, or even longer. But there's a lot of companies that haven't, and I think for those that haven't, just where to start can be a challenge to overcome. Right? How do we put that department together? What should those goals be? What should the expectations be? I think that's a significant challenge. Also, just operational constraints. Food plants are built and run a certain way, and that's to be as efficient as possible, and to be able to implement sustainable practices within that plant and how waste and byproducts are gathered so that it doesn't affect the efficiency of that plant. That can be something also to overcome. And from my perspective, food safety rules, having been in the food business for so long, things like FSMA and state regulations around how waste and byproducts are captured and held, I think that can be a really large challenge. And really the importance of getting not only internal quality and regulatory support, but then engaging others to make sure that whatever those new practices would be will fit within guidelines or technical or corporate requirements.
That's great. Okay. Let's see. Steve, do you want to add anything?
Yeah, I think, when we look at food production and the opportunity from a technology standpoint to sustainably handle byproducts or food waste, I think one of the biggest constraints we see is the type of materials, which I know we'll touch on further on in the discussion, but I think logistics plays a big role. When you're trying to find a sustainable option, there is limited infrastructure for processing of byproducts and waste that come out of food production facilities. And so I think as we look at different technologies that are being implemented, the logistics can be a constraint. Finding something that's within a reasonable distance to process these materials can be a restraint for food manufacturers. And so I think as we look at the broad perspective, I think it's important to understand that as technology advances, the hope would be that we see more facilities capable of handling and upcycling these materials, whether that be through renewable energy, compost. I know we'll touch on that more as well.
Okay, that's great. And then David, do you have anything you want to add?
No, I agree with Steve. I think working with food producers on the West Coast, I think one of the biggest challenges is finding recycling options within a reasonable distance of the plant. I think that's a big one because there has to be an economic benefit as well to recycling. And I think distance to the recycling facility can be a big restraint. I think another one is contamination. So for example, we've been looking at diverting fruit and vegetable pulp and pomace to animal feed, but it has to be in pristine condition, meaning that you can't have gloves or other material in there that are non-food related. And so it does require the food producer to make sure that the food waste in that particular instance for animal feed is not contaminated. And even if it goes to an anaerobic digester, it's difficult for the recycling facility to take any contamination in the food waste stream to their facility. So that's a bit of a requirement in a lot of cases.
Yeah, that's great. So the next question I'm going to ask, you guys covered a little bit in some of these responses, but maybe there's more you want to add to this. So if you can discuss the different types of materials generated in food production and include the challenges of managing these materials sustainably. So I know, David, you were talking about contamination potentially with these materials, and maybe I'll have you go first with this one. So what are some innovative solutions to address the challenges? So like contamination, or other challenges you see. Yeah, I guess that's my question. If you discuss, what are some innovative solutions to address some of these challenges that you had mentioned?
Well, a lot of that has to take place within the plant, so it's not a technical solution or technology itself. It's just operational procedures to make sure that there's no contamination. I'm going to add, though, that you talk about the food waste, and the food waste across the U.S. really reflects the regions we're working in. So in California, for example, I'm working with fruit and vegetable and berries. There some poultry, but we see a lot of pomace and we see a lot of pulp in this on the West Coast from Washington through California. And so the way we're managing this is a little bit differently, say, than what they're doing in the upper Midwest, where the food production is slightly different in that region than, say, on the West Coast. And what we're doing here, I can give an example. There's a company that is producing fruit and vegetable waste. They're producing juices and that kind of thing. And so the pomace or the pulp, right now, we take this to a digester who will only take fruits and vegetable waste, will not take any animal waste. And so we were able to find a place to divert this from the landfill to producing natural gas.
That's great.
Yeah, that's great. Thanks for going over that, Dave. Steve, I'm gonna have you go next with this one. If you
Yeah,
have
I mean,
anything.
as far as materials go, we generally try to classify when we're looking at a sustainable option into 3 categories, and that would be retail or packaged goods that for one reason or another need to be diverted, bulk solids and bulk liquids, and they all have different challenges around them. Some are easier than others. Yeah, I'll speak to the liquid side. Liquid waste that's produced can come in different forms. It can be waste waters, it can be slurries, it can be sludges, and then the level of processing that needs to take place on those materials, it can vary from just production waste that goes right out the door into a tank to facilities that have various levels of filtration. And again, as we've touched on the economics, it can be a constraint economically to process these materials in-house. It's not cheap. And I think the upside to that, though, is as we're seeing technology advance, conserving water is important and hauling water is not cheap. So I think as we look at some of these wastes, it's important to see how we can help at the production level to reduce that waste on site so that we're not transferring it somewhere else. But I think in combination, there are very good solutions to those liquid wastes. As Dave mentioned, energy production is a really big one through anaerobic digestion. But then finding something that is economically feasible inside of those facilities to reduce that water that needs to be moved off site.
Yeah, that's great. That is interesting I think one thing we don't keep in mind when we're talking about this is to process all of it, the amount of water that's needed or that comes off of it. I think that's great. And then Todd, if you have anything you want to add?
Sure. I mean, I'll talk about one of these material types, but before I do, I'm going to echo a little bit of what Dave said. Sometimes the answer is a technology solution, but a lot of times it's a change of practice in the plant. And I think that's where, and I think Dave and Steve would agree, I think that's where the importance of working with someone or a group with food experience, right, that kind of speaks the food language. Because a lot of times it's how that material is gathered within the plant, how it's shipped. I think that's very important about how it affects that plant for some of the reasons we talked about here a little previously. So the importance of working with a group that's not only just on the waste sustainability side, but also speaks the food language. Steve talked about bulk liquids. I'll talk about bulk solids and some of the challenges. When I think of bulk solid, I think of an IBC of dough or a Gaylord tote of melons. That's one of the material types that we can categorize things as. Oftentimes those are easier because they are in bulk. They don't involve packaging. But one of the challenges we can have with bulk materials is at the unloading process and whether a plant is set up to handle, can an anaerobic digester take a load of melons directly? The answer is probably no without some sort of additional loading equipment? Or can a compost site take a certain type of bulk material because of its, it's how it's handled at the site? So I think bulk material in general can be easier to handle, but it does come with its own challenges, especially at the delivery point.
Yeah, that's a great point. I mean, what would a compost site do if someone showed up with a, like you mentioned, bulk dough, like a
right.
What does
there
that
are challenges around that.
Yes,
absolutely.
Yeah. Interesting. Okay, we will move on to technologies, and I have a few specific questions for each of you, but then I'll let the other two also give a little input if that's okay. So I'm going to start with Todd again for this one. Deep packaging, I think, is something that we don't hear a lot about. We know that most of our food is packaged, and we know when it expires, it's got to go somewhere. So could you elaborate on the logistical challenges and benefits of depackaging food waste at the industrial level, and how this process contributes to overall waste reduction efforts?
Yeah, absolutely. Steve alluded to retail goods, and Rachel alluded just anything in a package. If you think about the vast array of packaged goods, whether it's potatoes in a plastic sack versus anything else as you walk through a store and pull things off the shelf. Really, we're always looking at how do we separate that packaging, that plastic, that metal, that poly, that cardboard. How can we separate it from the organics to then do good with the organics? So just as an aside for the food people that are on here, when I talk about organics on the waste side, I'm talking about something of an organic nature, not a food type that's been classified as organic or non-GMO or that type of thing. So really any food or material that can then be used in any of these processes, I'll refer to as organic. So we're separating the packaging from the organics, and that's what a depackager can do for us. It's a mechanical process that food stuff in its packaging can go into the equipment, and ideally you end up with a fairly clean stream of packaging, and then a fairly clean stream of organics that packaging can then be recycled, ideally, and those organics can be used for good, whether that be digestion or compost or any number of things. Depackaging, depackagers, there's multiple manufacturers out there. We have some wonderful ones here in the States, even here in Minnesota. And there is an art to it as well as a science. But depackaging units are really they're kind of at the front of the effort to collect retail goods and to then do good things with the organics inside. So the benefits are somewhat obvious, right? We can get that good stuff out and do something good with it. The challenges really come around packaging. And, I attended the Ram Swana show here in Minnesota yesterday, and there was a lot of conversation around packaging and packaging types. And I think that that's good, because oftentimes what you end up with outside of depackaging is a material that, unless it's a straight cardboard package or a straight aluminum can, it's very difficult to then segregate further and be able to recycle once it goes through that process. And there are some packaging materials that really can't be recycled. You get multi-layer poly, that sort of thing. So it's not really a fault of the packager per se or the process. It's a wonderful process. It's really, okay, now what do we do with the packaging that's left? Because often it's impossible or very difficult to recycle once it goes through that process.
Thanks. That's great, Todd. Steve or Dave, do you have anything you want to add? No,
I
that's
think
okay.
that you covered it really well.
Great. Okay.
Yeah.
So you brought up composting. Steve, this question's for you. Can you discuss the benefits and challenges that large-scale composting facilities face, and how they're leveraging technology to optimize processes and handle higher volumes?
Yeah, absolutely. Composting, just really quick as a general oversight, not to get into overly technical discussion, is an aerobic process. I mean, it's used to decompose organic material. It's been around forever. Even in a controlled environment, farmers have used it for thousands of years to get rid of waste materials. It's a very effective process. Some of the challenges, it is in most places, it's considered a nuisance business. If it's done correct, it is a great process, and the byproduct from composting is a valuable fertilizer. As far as constraints go, again, it falls back to logistics, food production. Wherever you're manufacturing your food compared to where you have a compost facility needs to link up logistically so that you can cost effectively move material to a compost site. And so oftentimes that puts compost sites close to heavy populations. And there are odors that come along with composting food waste. And so that becomes a big challenge for composters. It's kind of the wind and solar discussion that we want renewable energy. We just don't want it in our own backyards. And so there becomes a challenge of figuring out odor, truck traffic. These are things that need to be considered when you look at composting. The other component would be the compost that's produced can be sold in bulk. It can be bagged and sold at retail. And composters a lot of times will run into operational constraints, finding effective ways to move their byproducts cost effectively, which then raises their tipping fees to receive material. So if they're not able to find a good market for the compost, it becomes difficult to offer fair tipping fees for production facilities that are producing food waste. There's a lot of technologies around composting that are advancing that help with odor, reverse airflow, drawing air through a compost pile as opposed to turning those piles and letting that methane release. So I think that as we continue to advance, technology is going to be and play a big part in this. But really, it also comes down to just operation effectiveness to make sure operators are running these sites correctly, that they truly have expertise in this space to manage these sites correctly.
That's great. Well put, Steve. Thank you. Todd or Dave, do you guys have anything you want to add?
I don't know.
Yeah,
Steve covered that well.
that was a great presentation. And as I've been visiting compost sites throughout the West Coast, there's a lot of science behind it. And I'm finding also that not all of these sites can accept all types of food waste to include into their green waste, meaning leaves, brush, that kind of thing. So they're all very particular. But what I've seen is everything from open field type compost facilities to another compost facility that was highly advanced, where all the compost rows were actually enclosed. And so they're capturing any of the methane that way, plus any runoff water. So there is technology involved, and I think it's advancing, like Steve said, pretty rapidly. But it's a good alternative for recycling food waste if you can find a facility that's relatively close to the plant that will accept food waste.
Great. Okay, cool. Thanks, guys. Thanks for adding on to that. David, I know we had a question in the chat about how we're working to remove methane from food waste, and we can answer that more later too. But I think what you just said helps answer that somewhat, that capturing the methane within the pile before it escapes into the atmosphere. And going off of that, Steve, I'm gonna hit you with another question again, right off of the last one, since we're talking about methane. Anaerobic digestion. Can you explain the environmental and economic benefits of anaerobic digestion compared to other waste management methods, and how advances in this technology are driving sustainable practices within the food industry.
Yeah, absolutely. Just really quick from a slight technological perspective, it's the opposite of compost. So you're absent of oxygen in an anaerobic digestion process. So you're removing oxygen from the process using methanogens to break down organic material to produce methane. Really quick, I saw, Rachel, there was a question specifically addressed towards methane from the decomposition of food waste. Julie had asked, how do we handle the methane that's produced from food waste? And anaerobic digestion is actually one of the best solutions here because it's contained, very quantifiable capture of carbon, and measurable in the production of methane. So if we can divert food waste to an anaerobic digestion facility, we're able to break down that material. The methane's broken, or released. Basically, you release the methane, and then traditionally that was cleaned and oftentimes run through electrical generation generators on site to produce electricity. That electricity was typically put onto the grid or used internally. So what we've seen in most recent times is a big push to produce RNG, and that's taking that methane that's produced, cleaning it to pipeline quality, and then moving that into a market. California has a large transportation market that's been driving anaerobic digestion facilities and technology growth in this space. So again, back to some of the hardships there. Logistically, we're at a lack of infrastructure for anaerobic digestion facilities. If you go overseas, look in European nations, the amount of anaerobic digestion facilities that exist far exceed what we see here in the United States. And that I think that's coming here. We're seeing a stronger push for a need for these facilities to be built. We're seeing larger investments into this industry. So I think that's a really good thing. But again, it does come with challenges. They can, again, it's like David mentioned, there's a lot of science behind it. It's a highly scientific process. There's a lot of biology that goes into it. And when you disrupt that biology, you end up with some problems. And so in a lot of states, it is considered to be a nuanced business because of those challenges, the odors that come with it, the truck traffic that comes with it. And so I think it's important for food manufacturers, the groups that are looking to produce methane or manage and operate anaerobic digestion facilities, and also legislation to all kind of come together to work towards a common goal. Because it is difficult when you have a facility that is necessary, but also causes some nuances for its neighbors. So how we can work together to build more facilities, give us that infrastructure, but then also kind of work from a technological standpoint to get rid of some of those challenges. And we are seeing advancements there. Odor control, emissions control, those are all important when it comes to anaerobic digestion.
Absolutely. Yep. Todd or Dave, I'll have you go first this time if there's anything you want to add to what Steve just said.
No, I thought that was a really good presentation about anaerobic digestion.
Yeah.
The only thing I can add is that contamination, it is a science. Contamination here and the kind of materials that these digesters accept is really critical. These microbes that break down the food waste are somewhat vulnerable and fragile. So if the pH level if there's something wrong there that's introduced, could actually kill off all these bacteria that break down the food waste, and could be, then the digester has to start all over again. So they have to be really careful about what they receive for food waste.
Thanks. Todd, anything you want to add to that?
I would just say, Dave, that's a great point. I think we've all run
Yes.
across that in our careers, and it's something to keep in mind. You know, a wash water with a certain chemical in it can cause a nightmare for a digester. I would just say, you know, as we talk about the technologies in general, there isn't really a best overall technology from my perspective. It's all about the best fit.
Yeah.
And I think when we get into the next question, I'm going to talk a little bit about some companies that have multiple streams and what fits might work. But just to keep in mind that digestion works for some products, compost works best for others. You know, animal feed might work best for others. There isn't kind of a one size fits all here. That it's kind of pluses and minuses of each.
Yes, indeed. Okay, Dave, this next question's for you. What are some recent technological advancements or innovative solutions that show promise in further reducing food waste along the supply chain? So how do these innovations address key pain points or inefficiencies?
Yeah, you know, I don't know if you'd call it a technology, but I think we missed one, and that's upcycling. And that's
yes.
becoming an important factor in food waste management. And I can give you an example again. There's a company based in California that takes, well, two streams. One in an oat milk factory where they take the oat waste, and then they also have equipment at a soybean milk factory, which they take the okara. And in both cases, then immediately after, because it's all human consumption, still contained in the human consumption space at the plant, they take this leftover material like the okara, they run it through, dry it, and create a flour for it. So this is typical upcycling, a good example of it. And then what they do with it, the company will sell the flour, but they also make mixes, cooking mixes, cake mixes, that kind of thing, that are branded and out on the shelves in the grocery stores. So that's a prime example of upcycling. Relatively new, requires a lot of close management within the plants to be able to do this. So it's not necessarily an easy thing to do, but it's a cost-effective means of recycling or upcycling some of the waste material.
That's great. Thanks, Dave. Todd and Steve, just because we're running short on time, I'm going to hold off on you guys for this one, and I'm going to move on to operational efficiency because I think this is really important that we address this. So if you can just maybe talk about some strategies for implementing sustainability without negatively affecting operations. And I will have, Todd, if you could just go first on this one, since you said you wanted to jump into it anyway.
I will. And I know we're short on time, but I think Grace asked a really important question that I think we should talk about because it kind of overarches all of this. I think she asked about what happens if it's good for human consumption, what are we doing there? You know, my approach, number one, if byproducts can be used for human consumption, whether they can be donated, given away, sold at a lesser rate, that is absolutely what should be done with that. And that's what I would suggest to anybody that I'm working with. Two, can they be upcycled? You know, upcycling is a great solution. I think it's somewhat rare to come across products that can be upcycled, but it is absolutely a solution. So kind of before we get into all of this stuff, I think those two things should be considered. And interestingly, we do work with food pantries that take excess product from producers, and we work with them on the back end. So once the food pantry is unable to, you know, they have product that's gone bad or product that they've spilled, then let's do good with that. So, but I think it's important to address, yes, if it can go for human consumption, 100%, it needs to go for human consumption. So, okay, as far as operational efficiency, when I think of sustainability, you know, we often think of environmental practices. As far as food production goes, I think of it in sustainability in three ways. I think of it operational. Is it a sustainable practice operationally? Can it work in a plant and work long term? Is it economic, right? Does it make dollars and cents? And environmental. I think if you don't have those three, the environmental portion will not last long term. And that's the goal here, is that we have practices in place that last long term. So I look at three of those, and operational is one of those. And I think part of the operational, to have a sustainable practice operationally, is really to understand the operation. We make a concerted effort to spend time in a plant, meet the people, understand the product and the process prior to trying to come up with a sustainability plan or solutions for waste and byproducts. Because again, if it's not going to work in the plant, it's not going to work long term. Now, often there's training around that, maybe some new processes, and new processes aren't always the most fun, right? But at the end of the day, they have to be as efficient or more efficient than what's being done now, or it's not operationally sustainable.
That's great. Steve or Dave, if you want to quickly add anything to that before we move on to the future and economic landscape.
No, I'm good. I think that.
Okay.
That was well covered.
Great. Okay, thanks so much. All right, so now we'll move on. I'll change my slide here. So the future and economic landscape, an analysis of the current landscape and any future trends. Dave, I'm going to have you go first for this one again. How do consumer behaviors and preferences impact the food industry's approach to reducing food waste? So are there specific consumer-driven initiatives or demands that are driving the change within the industry?
Yeah, I've been reading about consumer demand, and I mentioned this earlier, particularly the younger consumer. Sustainability is really important, and they will direct their buying behavior towards those companies that are clearly sustainable. And they do this by going on the company website and checking them out, and then you have a loyal consumer. So I think that the younger consumers in particular are much more aware than, say, older consumers. I'm going to mention, and someone posted something on the chat, the Upcycled Food Association, which is relatively new, now has a certification mark that companies can put on their packaging. And I think that's going to become increasingly more important, again, as younger consumers develop their buying habits. And then another one is refed. I think what we're seeing from refed is consumer education about food waste, sustainability, management practices, that kind of thing. So I think refed is becoming extremely important as well on the educational side. And of course, Brass Tacks Initiative, you're doing the same thing. And I think it's having an impact. It's slow, but it's directing people towards companies that are dedicated to sustainability.
Thank you very much for that plug for us there, Dave. That's great. All right, and then Steve, if you have anything you want to add?
Yeah, I mean, I think for the processing side, I think what we're looking at is a strong push from an investment standpoint from a much larger group of investors who are putting, I don't want to say that this hasn't been done before, but real money is being invested into the industry. And I think it's important because we weren't getting that push prior. And I think that's what's going to bring this to a point where we can effectively say we have the ability to handle these waste streams sustainably, because prior the effort could be given and the infrastructure just wasn't there to handle it on a broad perspective or a large scale. And so I think as the investment side, as we've all talked about, everyone's touched on the economics of this. If the economics don't line up, it might take place from a subsidy standpoint for a short period of time, but it will fall off. And I think if we can get to a point where this is becoming a genuine industry supported across on a broader perspective, we're going to get a buy-in that's much more genuine to start handling these byproducts and waste streams sustainably. So
well put. Thanks for that, Steve. Todd, if there's anything you want to add?
No, that's covered. Thank you.
Sure. Okay, so we have a couple minutes for some more questions. And let's see, here's one from Alexis Taylor Baker. How are you addressing microplastics in the compost, and how well do the depackagers get rid of items that contribute to the microplastic contamination?
That's a great question.
It is a great question. Steve, you were talking about compost earlier. I'll let you go first with this question if you want to answer.
Yeah, microplastics are very difficult when we're looking at PFAS. It is a very hot topic right now. We are finding more and more that microplastics are much more widely spread in almost everything. Compost is one of them. At the end of the day, the microplastics are ending up in our water.
Yeah.
And so really what we're looking at is the need for a technology advancement, which we are seeing, and there's a lot of data coming out about filtration systems that can remove microplastics from water, because that's ultimately where it's going to end up, whether it be through compost, anaerobic digestion, fertilizers. So really what we need to see is the ability for compost facilities, wastewater treatment plants to actually remove those microplastics. And I think we will get there. And then I think there needs to be a general knowledge and a better understanding of how these are affecting humans, nature. And once we start to be able to remove them, the destruction of them is important as well. And I don't know if we quite have an answer for that yet, but I think the consolidation and removal is step number one. And I think we're starting to see, again, technology lend towards the efficient removal of them. It's just going to be the implementation of those practices that we need to see take place.
Yeah. Todd, is there anything you want to add to that?
I think it goes back to, I think Steve really covered, okay, how do you get rid of them once they're there? I think I would also like to focus on how do we slow down the generation? And that comes back to, we talked a little bit about packaging. There's so much of a focus right now on food packaging, eliminating plastics where possible. And I think that's really important. So slow down the front end, come up with a solution on the back end. But until we change our packaging, I'm not sure we're going to get in front of that wave of microplastics.
Yeah, that's great. I think we can do one or two more questions, but I'm going to put this slide up really quick just in case some people need to jump off because we are past our time right now. So if any of you want to get in touch with these guys directly, this is their contact information up on the screen. The QR codes will send you directly to their LinkedIn accounts, and all of them have said, feel free to reach out to them through a message on LinkedIn or to shoot them an email. Company websites are also great, but if you want to take a screenshot of this or, scan the QR code, whatever it is, go right ahead. I'm just going to stop recording now because I need to for Food Waste Prevention Week. They only want this to be 50 minutes. Or I'll do that later. It's fine. But if you guys don't mind, do you mind taking another question or two?
I love it.
Okay. If you guys want to throw some more questions up in the chat, go ahead. I saw one up here. Okay. So Tori asks, how effective are anaerobic digesters in water treatment facilities in terms of food waste? Who would like to answer that one first? Or can we answer that one?
Yeah, I can touch on it from just a technology perspective. Wastewater treatment plants, typically food waste is a challenge for your typical wastewater treatment plant because it's going to overload the system. There are a lot of facilities that have upgraded and do have the ability to take food waste. So again, I don't want to sound like a broken record, but some of this is infrastructure being updated, technology advancements being put into place on a broader perspective, because anaerobic digestion does a great job of reducing the volatiles in waste. The problem is it's a typical digester is not going to remove enough that you would be able to discharge that water. So there are steps post digestion that need to take place before that water is potable or clean. But it is a great first step, especially when you're looking at food waste, because food waste is very volatile. There's a lot of usable energy in there. So as far as its effectiveness, it is a great pre-treatment to water treatment. And a lot of wastewater treatment plants have anaerobic digestion infrastructure. A lot of them need to be updated though. Yeah. So.
That's great. Thanks. Todd or Dave, do you guys want to add anything to that?
No, Steve.
No, I think that was a great answer.
Mm-hmm.
Nice job, Steve.
Yes. Nice job. All right. It looks like I'm looking here. I think, did we get all the questions? Well, Catherine, a lot of questions about anaerobic digestion today. It looks like why anaerobic digestion is a great solution for large urban areas. Why is anaerobic digestion a great solution for large urban areas? Maybe is the question. That's from Catherine.
Yeah, I think that would depend a lot on what the feedstock stream looks like. I assume if it's related to a large urban area, we're talking curbside, which kind of brings its own challenges of separation. And feeding a digester with curbside, there's challenges there with levels of contamination. And then where does the liquid from the digester go, right? In the digestate, that has to be taken somewhere. So I think there's more and more interest around curbside going to digestion, sorted, and the organics going one way. That's a challenge. But then also there's challenges around digestion. I think Steve alluded to technologies helping with odor and things. But some of that's still there. And anytime you're handling organics. And so I think you would look at that facility, kind of away from that population. And then just considering freight, right? What does freight look like? Fossil fuel usage, that sort of thing. So like a lot of these technologies, it's not about a perfect solution. It's weighing the pluses and minuses.
That's great. Good answer. Dave, was there anything you wanted to add?
No, Steve, you've had experience with, there's a digester that's powering a small town in Minnesota for their power. And I think that's pretty incredible. We took a tour, I don't know, a couple of years ago, and the operation was very impressive. I don't know if there's anything to add there, but maybe not large urban areas, but smaller urban areas. This could be a means of, supplementing their power needs.
Yeah. Yeah. All right. Well, with that, I just want to thank you guys for being here and doing this. You did a great job, I think, covering this topic. I learned a lot, and I know a lot of other people did as well. If anyone else wants to find out more about the Brass Tacks, we do programs a lot. Feel free to reach out to me directly or go through our website, find out what we have coming up next, or scan the QR code there. Thank you all for being here. And that ends our webinar today. Take care. Have a great day.
Thank you, everybody.
Thank you.
Yeah. Thank you, Rachel. Bye.
Yeah. Thanks, guys.